So basically, we have two simple concepts we need to show you. Two relationships, just like yesterday. If we're intersecting inside the circle or intersecting outside the circle. If we are intersecting inside the circle, then it's really weird here. The product of the segments is constant. Product of the segments is constant. And what that means is take a look at segment AD. What are the two parts of AD? AE and ED. Okay, so if I take AE and multiply by DE, that product, that outcome, is going to remain the same no matter what two segments are intersecting. So basically, we get this result where you take all four pieces and you multiply them together. So AE times DE is equal to BE times CE. And that's if we intersect inside the circle. We'll see what that looks like here in just a minute. Again, this is on your reference sheet. Now, on the last one, where is the intersection? Outside. So here's what I'm going to tell you guys to do. This is going to be, so you might want to write down on your reference sheet. The outside times the whole is equal to outside times the whole. And that's the relationship. Outside times the whole thing is equal to outside times the whole thing. So tell me what that actually means if we're looking at that diagram.
They equally covered.
Okay, but yes. Well, how would I set that up based on those values, based on those letters? Take segment AE. What's the outside portion? Okay, what's the whole portion?
ABE.
So just AE. So if I take BE and multiply by AE, so the outside times the whole, what would that equal? Go to the other segment. What's the outside length?
DE.
So DE times CE, and there's our relationship. Outside times the whole is equal to outside times the whole. Doesn't matter if I have tangents. Does it change anything? Let's take a look. Let's do this, see what the tangent's over here. Again, if the intersection's outside the circle, it doesn't change because we changed the segment. If it's a secant or a tangent, it doesn't matter. So we look at the one over here on the right, the two tangents, and I take tangent AE. What's the outside portion of AE?
Do what?
Okay, what part of segment AE is outside of the circle?
AE.
AE, okay. So again, that's the outside times the whole. So what's the whole length of AE? AE. And that's going to be equal to, now take the other tangent. If I look at BE, what portion of BE is outside the circle? BE. And what's the whole length? So then I have AE squared is equal to BE squared. Let's think about this for a minute. If AE squared is equal to BE squared, what does that tell you about AE and BE? They are congruent. Therefore, if you have two tangents that are intersecting, then their lengths are the same. Anytime.
No matter what.
No matter what. Anytime we have two tangents intersecting the same circle, they must be congruent.
Even if it was like,
That's not a tangent.
but if they only touch one spot.
That's not a touching one spot. If you extend the line, it would be intersected twice. Okay, so they have to be tangent to the, we'll call it the side of the circle. Okay. All right. So that's tangents. It's a special case. But notice if you did the formula, outside times the whole is equal to outside times the whole, you'll end up with that result anyway. All right, so you can memorize this. You just memorize outside times the whole is equal to outside times the whole. If I look at this portion over here with a tangent and a secant, again, it doesn't change the setup. The intersection is still outside the circle. Therefore, it's outside times the whole is equal to outside times the whole. But in this case, when you have a tangent, and I think the reference sheet simplifies that by calling that t, we get the tangent squared is equal to CE times BE. But again, that's because outside times the whole. So we get AE squared. All right, and that's all you guys need to know. You know the relationship. So again, outside times the whole is equal to outside times the whole. And that's if it's intersecting outside the circle. If it's intersecting inside, you multiply along the same segment. So BE and CE get multiplied. AE and DE get multiplied.
What ones?
They're going to be on the same segment, Mason. So if we look at segment BC, it's the two parts of BC. Okay. All right.